Okay, I'm Walker Anderson, and this is my circuit building project. Basically, we're just going to be trying to get sound out of this speaker from this CD player using these wires and some resistors and capacitors and other coiled wires and whatnot. So I'm going to start just by getting the raw signal, connecting some of these wires. I already have some of them connected, but here. Okay, so that's the raw signal. Now what we're going to do first is we're going to add a resistor. And this resistor is, the colors are brown, black, brown, which is a 100 ohm resistor. So if we connect this here, connect it. You can tell that it's a lot quieter with the resistor here, and combined with the resistance of the speaker, which is an 8 ohm resistor, we have 108 ohms of resistance here, and as you can tell, compared to just the raw signal, it's a lot quieter. So now we're going to add a second resistor in series. This resistor is also a brown, black, brown resistor, meaning it's also 100 ohms. So if we're going to add that to our original mix, which, as I said before, was 108 ohms of resistance, this should be 208 ohms of resistance. Okay. There doesn't seem to be much difference in the volume. It might be a bit quieter, but it doesn't seem to be that much quieter than the 108 ohms of resistance. Again, this is 208 ohms of resistance. Alright, so that's in series. Now I'm going to connect these two resistors in parallel. Gotta think of how I can get it there. Another alligator clip. Some reverb for you. Okay, so now the resistors are set up in parallel. Now if we're going to calculate the resistance here, hold on, I'm going to get my phone calculator here going. Have to add up the reciprocals of all of the resistors. So if we have an 8 ohm resistor, it's going to be 1/8 plus, we have one 100 ohm resistor, so 1 over 100, and then another 100 ohm resistor, and that's going to give us, then we're going to take the reciprocal of that answer, and that should give us what we need. But first we have to find a common denominator, which I believe is 200. So that would mean we're adding 25 over 200. And then plus 2 over 200. And then plus another 2 over 200. Actually, I could just do all that math in my head. I don't know why I'm doing this on the calculator. 25 plus 2 plus 2, that would equal 29 over 200. Take the reciprocal of that to get the answer, and that would be 200 divided by 29, which gives us 6.89 ohms of resistance. Would I have to move the decimal place over if I did it like that? Yeah, I would. So that would give us 68, or would it be 689 ohms of resistance? Yeah. And it doesn't sound, as far as the quality of the sound or how it's different, I mean, it's definitely quieter than the raw signal, but it doesn't seem as quiet as when it was in series. Okay, so we're done with resistors. Now we're going to move to one of these variable resistors. So we're going to connect to the middle terminal and the other terminal here. And this variable resistor is 5,000 ohms of resistance, and it's definitely quieter than the other resistors, not by a lot, but it's definitely quieter. Okay, so there's a variable resistor. Now we're moving to capacitors. We're going to go with one 10 microfarad capacitor here. So you can tell that it's taking out a lot of low end. It's a very bright signal with just one 10 farad capacitor. So now we're gonna add another 10 farad capacitor in series. Now when you're adding capacitors in series, you take the reciprocal. So if these are two 10 farad capacitors in reciprocal, that would be 2/10 add together, but we need to take the reciprocal to get the answer. So it would be 10 divided by 2, so this would be 5 microfarads. And you can tell it's it's even brighter and more high end, less low end than with just one of the capacitors. So now that we've done it in series, we're going to do it in parallel. Okay, so here's our one farad capacitor. Now that they're in parallel, we don't have to do the reciprocal, so we just add them up. So this would be 20 microfarads, and it's definitely taken some of the low end out, but it's a lot more. There's a lot more low end and blending than with the when they were in series with the 5 microfarads. All right. So there's our capacitors, and now we've got these coils of wire over here that we're going to be connecting up. Come on. So we're going to start with this red wire, hooking it up. So our goal here is to find the most inductive of these. So we do that by comparing it with the raw sound. So usually the red one, it's not really all that different. Might be a bit brighter, but other than that, I mean, it was kind of hard to tell. So now moving on to this green wire. Let's work here. Oh, I picked up the wrong yellow alligator clip, which is why that didn't work. That sounds, in comparison to just the raw power, it sounds like it's a little bassier. It's got a little more low end in it. Yeah, I'd definitely say that this one, it gave it a little more deeper of a sound there. Now I've got this copper wire. Come on, alligator clip. I like this one better. I don't know why I keep unclipping it to this first thing. I don't need to. So that's just finicking. Come on. I mean, I hear something. I can actually hear something just by holding both ends of these. I wonder what that says about my inductancy. Let's see if we can't get something out of here. There we go. See, this one doesn't sound all that different either. Let me just give it a quick. Come on. Yeah, not that different. So yeah, I would say definitely the one that changed it the most would be this green wire. So I'm going to say that that one would be the one with the highest inductance, or inductance, or however you say that. So now we're going to hook this green wire up to one of these capacitors, and then we're going to see what happens. Doot, 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 doot. Clip. And yeah, the tone is definitely a lot brighter, even though this wire without the capacitor made the tone pretty deep. Which I just cut out here, but that doesn't really matter. One thing that I am now just remembering that I forgot to do was with the 5,000 ohm variable capacitor. I already showed you what happens when we hook it up to this middle terminal and one of the other terminals. Yeah. And hold on a quick second while I get that set up for you here. Now there's that, and then if I turn this knob over here, turn it. There isn't a difference really between the sound at all, turning it from the left and the right. So yeah, come on. Yeah, I didn't notice much of a difference. I'm supposed to turn the volume all the way from left to right with this resistor in, and it didn't seem to make a difference. So yeah, that's pretty much it. Okay.